Good afternoon. Thank you for being still here. So the idea of this session is to put serverless into a slightly different context to see how we can build highly available active-active multi-region architectures. And so I don't know if everybody was here before. So my name is Danilo. I'm part of the evangelist team, and I'm focused on serverless technologies. And in this case, we are looking into what availability means and how we can improve availability with multi-region. So I'd like to start with some fundamentals here. And let's see what availability means. So availability means how much time during normally a year your application is responsive for your customers. Normally, we express availability with a certain number of nines, so 99%, 99.99. And as you can see, if we want an availability of 2 nines, that means that we can be down in a year more than 3 days, almost 4 days. 4 nines is less than 1 hour. 6 nines is 30 seconds. So it's, as you can expect, it's much difficult to move from one step to the other. But there's lots of tools that we can use to build availability. Actually, if we have an architecture that has multiple components, let's imagine this is my web application server, and this is my database server. The overall availability, if I have components that are put in series, will be the product of the availability of the single component. And that usually means that my availability is going down. Because if this product has an availability, so X as my web server has an availability of 99%, 2 nines, and my database has an availability of 4 nines, if I do the product, by default, this will be a number that is smaller because I'm multiplying 2 numbers below 1, and the number is going to shrink and shrink. So putting components in series is always making your availability worse. What you can improve is if you can replicate your components. So instead of having a single web application server, I put 2 web application servers in parallel. And then the availability will be making the hypothesis that a single web application server can sustain all of the load. Then at least I need one of the 2 to be active. So the overall formula will be this one, so that the probability that not both are down at the same time. And in this case, the availability grows up very quickly, because if I have a component that has a quite low availability of 2 nines, if I put them in series, I get, in parallel, I get 4 nines of availability. So I'm increasing a lot from days to minutes by just putting the components in parallel. And if I do 3, normally we always say that for availability 2 is not a good number, 3 is much better. One of the reasons is because if you lose 1, then all the load goes on the other components, and then you have a single point of failure. So if you can do 3 elements in parallel, then from 2 nines you go to 6 nines. So lots of quite a good level of availability. So we see that redundancy is really key for increasing availability of your architectures. And that's why we have this globally distributed architecture with AWS. This is our global infrastructure. Those are all the regions that we have in orange. And in green, you see the new regions that are coming. Actually, I couldn't update the slides, but during the night, we launched the region in Stockholm. Now in the AWS console, you can deploy in EU North 1. In Europe, we have in 2020 the new region coming in Milan, in EMEA, another region in Bahrain, and in Cape Town. So it's growing a lot. And each of those regions here you see as a number. That's the number of the availability zones. That's because, as you probably know, our regions are never single data centers, but each region is composed by at least 2, most frequently 3 availability zones. And each availability zone is a different cluster of data centers, usually built with a different security profile, so that if one availability zone has a minimum risk of flooding, the other availability zone can't share the same kind of risk. And now that we see, this is exactly the physical equivalent of spreading our architecture with parallel components. If I work in Ireland, for example, I have 3 availability zones. I can distribute my architecture and build the parallel availability that I was mentioning before. So normally, if I build a traditional architecture with EC2 or containers. I need to have a load balancer that somehow is distributing the load across different availability zones in my region. And then I have to deploy my application across multiple availability zones. So maybe I can use an auto-scaling group for that, or I can manually choose which one I want to use. If I go, and the next step is to go multi-region. So if I want, I can also replicate my architecture across 2 different regions, for example, Ireland and Frankfurt, if I want to stay within the EU. Or maybe I can do Ireland and Oregon and Singapore, so I get a global coverage of the world. In that case, I can use the DNS to send the user to the closest region, and it starts to be quite interesting. It's quite a complex architecture normally to maintain. With serverless, things are much easier, because when you use high-level services like Lambda or Amazon S3 or DynamoDB, you don't need to pick and choose the availability zone within the region, but automatically the service is distributing the Lambda function, the storage for S3, the database for Dynamo, across all the availability zones. So you just need to use the service, and already this availability that comes from having components distributed across multiple data centers comes out automatically. And serverless, if you're still in this track, probably you understood that there are some advantages. So I'm not spending time here, but there are lots of advantages. And why you should build maybe a multi-region architecture with serverless, and maybe you can build it ActiveAactive. Probably the most important reason to go multi-region is latency. Let's imagine that you have a user in Europe, and you have your application. You have your application in Europe, and you have users coming from the East Coast and from Australia. There's nothing we can do against the speed of light. So you have hundreds and hundreds of milliseconds that are wasted here. And normally, when you go above 100 milliseconds, people start to feel that the interface is not as fast as they expect. Above 300 milliseconds, it really feels bad. So customers notice that the application is not working as they expect. And also another reason can be disaster recovery, because when you deploy, for example, an application, you can make mistake. You can use canary, whatever you want, but at some point a deployment can break a whole region. Regions are isolated, so it's very difficult unless you replicate the error that this error goes in another region. But if you bring down all your application in US East, then you can use, for example, the DNS to send all the users to the other region for some time. And we will simulate this environment briefly, but it's probably one of the main reasons together with latency. For example, Netflix, they have a multi-region architecture, and they deploy region by region. So they start with one region, if it works, normally the region with less traffic, and then if it works, then they replicate. So that if the deployment is breaking something, they can quickly roll back by sending all the users to another region. In fact, Netflix was one of the first customers who started to talk about building multi-region architecture. They started to think about that in 2013, and it took them 3 years to go multi-region because it was very complex. Now, with some of the features that we launched over the last couple of years, it's much, much easier, and then we can build a multi-region architecture in less than 1 hour. So as you can imagine, from 3 years, it now takes less than 1 hour. What are the prerequisites? So the idea is that when you go multi-region, latency starts to be important between the regions. There's nothing we can do against the speed of light. So it's a distributed architecture. And whenever you have a distributed architecture, you need to think about what features you can count on. So there is a theorem. It's called the CAP theorem. Maybe you already heard about it. But the idea is that if you have a distributed data store, and most architecture at the end can be assimilated to be a distributed data store when you distribute them across components, then you can only guarantee 2 out of those 3 characteristics. So you have to choose 2 between consistency, availability, and partition tolerance. Consistency means that data is always consistent across all the different partitions. So it can be, for example, in this case, the multiple regions. Availability means that every request is fulfilled. And partition tolerance means that if you lose one of your partitions, then you're still able to respond as expected. So you're not losing data, for example, and you can still work correctly. So if you have a distributed architecture, you have to a distributed architecture like a multi-region, then you need to have partition tolerance, because that's a must. You can't lose data, you can't lose customer information. So you need to choose between consistency and availability. What you would pick up between the two? Who's voting for consistency? Who's voting for availability? Okay, it was easy because the title of the session is on availability. So, but the idea is really that you should focus on availability. Consistency, data consistency, is something that we can work on. In fact, we always talk, and we started to do that in Amazon, about thinking when you design an architecture to have your data to be eventual consistent, so that at some point the data will converge across the different components of your architecture, but you can't be assured that this happens now or immediately. There is an interesting white paper by Werner Vogels, the Amazon CTO. He wrote that in 2009, that is explaining also how to think about an eventually consistent architecture. If you think, for example, if you update the image of a product catalog, you can live with these images that take some time to be propagated across the network. You can't use eventual consistency if you're doing financial transaction, because I can say, okay, I buy this product and maybe the money will arrive sometime in the future. So the financial transaction is an exception, so you can do that. But for lots of the information that we have with our application, our websites, we can definitely live with eventual consistency, so that the data is going to propagate and take some time, and it's something that you should think of. Normally, this brings you to have something like design architecture that are idempotent, so that if the same operation comes again and again, you always get the same result. And this is an idea that usually helps building resilient distributed architectures. And on top of that, we need good network. And starting from 2016, we started to describe how we are connecting our regions with a network that we manage. This is James Hamilton, one of the great minds behind the infrastructure that we use in AWS. And this is the last update from a few weeks ago. So this is the Amazon Global Network. So all of our regions and edge location, with the exception of the 2 regions in China, are connected by a redundant 100 gigabit Ethernet fiber-based network. And the throughput that we can handle is very, very high, because there are thousands and thousands of fiber connections that we have for every connection. And if you look at this, if you look online, you can find also some interesting stories, because we worked specifically really in passing our own cables. For example, the cable that is connecting the West Coast to the US through Hawaii to Australia is something that is a project that we physically participated on. Now we have some projects also here to connect India with other islands. It's clearly an interesting project, and that means that if you move data from one region to the other, you don't use the internet anymore, but you use an Amazon managed network that is highly optimized. And one of the advantages is also that if there is a problem with the internet, you know, the public internet is composed by lots of networks working together with routing tables that are dynamically computed. If there is a problem, then the global internet can take some time to readjust to a specific change in the network. The network that we manage, we can react very fast, because it's something we manage directly. So when we consider this, then we need to think, how can I send my customer to different regions? So they arrive to my DNS, so you have your global DNS record, and then this can be send customer to one region or the other, to Ireland or US East, for example. And one interesting way to do that, that is one of the features of Amazon Route 53, is latency-based routing. So we can automatically look at the endpoint, if they are AWS regions, and send the user to the region that has the lowest latency. This can sometimes create strange results, because the latency is different than the traditional geography. But it's very effective, because it's really sending customer to where they work better. We can also do geo-based routing, where you can specify country by country. This is normally useful if you have like digital rights, or you have to expose different services depending on the geography, because in some countries you can do something different than in other. And here you can send users based on the country where are coming from. And we can also do just a weighted round robin between regions. So in case, for example, you distribute your architecture between Ireland and Frankfurt, maybe latency is not a problem within Europe, but you still want to have the availability of the two regions, and you can use a weighted round robin to send customer on one side or the other. And of course, Route 53 can monitor the endpoints and do DNS failover. So if the application is not working on one of the two sides, and this works with latency-based and other techniques, we send all the users to the other endpoint. You can configure health checks that check that the service is responding, and if there is a problem, we send all users to the other side. So now we can start to see that we can design a multi-region serverless architecture. So let's use, for example, US East. So US East and US West here. We can put our business logic in Lambda functions, and we replicate the Lambda function at deployment, nothing really complex to do. As I said, I would probably not deploy concurrently across all regions. I would start with one region and then eventually do the other one. Then we can use the API gateway. The API gateway has 3 ways to build APIs. You can build what the original way of the API gateway, now we call it edge-optimized API. And edge-optimized, they are designed for an internet-scale distributed population of users. They embed our content delivery network CloudFront. And the side effect is that you can't do latency-based with those APIs, because every customer will reach the closest edge location and then go to the API gateway. So you need to create a regional API endpoint. If you create a regional API endpoint, the API gateway will get out at a region level. So you get out in Dublin or in Frankfurt, for example. And then the API endpoint has a custom domain name. And then you can use Route 53 with your global public domain to do latency-based routing on the two custom domain names of the two regional API endpoints. So in this way, we can have a business logic that is distributed across region, and the latency is the driver. For data, we can use DynamoDB. So last year, we launched DynamoDB global tables. That means that you can create a table in one region and then replicate across multiple regions. And we will synchronize the content of those tables. We can't fight the speed of light, so normally it takes less than 1 second to have all the data at sync. That's why eventual consistency is important. But it's a very simple way to have a distributed data set. So to have this working active-active, you need to think about how you use your data. So if, for example, each customer is using their own data set, then if some customer go in one region and some customer go in another region, and then data is synchronized, everything works. If you have multiple customers working on the same items, and this item is in different region, then concurrency will not work, because this 1 second on average of latency will not create anything that works. For example, DynamoDB transactions don't work on global tables. So you can have transactions within a region and within an AWS account. But of course, it can't work in a region, because otherwise we would need to lock the record for 1 second and wait for the round trip with the other region. So it would not be something scalable. So at this point, we can set up a demo and see how this works. We can do the DNS-based solution. The DNS-based solution is we create a DynamoDB global table in 2 or more regions. Then we deploy Lambda functions in those regions. We put the API gateway with a regional API endpoint. And then we use Route 53 with latency routing to balance across all the different regions. And this is the overall architecture that we get. The customer here is redirected by Route 53 to the closest region, but the user, to go to the region, will use the public internet. It's the closest region that will use the public internet. To manage failover, Route 53 will change the result of the DNS. Normally, the DNS result, they have a TTL, a time to live. And Route 53 has a very short time to live. I think it's 30 seconds. I don't know if we reduced that. I didn't check recently. That means that after 30 seconds, the client will refresh the DNS. If one region is not working, the new DNS answer will send the customer to the other region. It's not super fast because you need to wait for the DNS refresh of the client. If you have clients that don't respect DNS refresh and TTL, sometimes this happens with IoT and embedded devices because they have a simplified operating system. Then this architecture will not work because they will maybe cache the DNS result for hours, and they will not move from one region to the other. To create a DynamoDB table is like normally you create a DynamoDB table. You only have to choose the primary key of the table. Everything else is flexible with DynamoDB. And then we have a global table panel. You can only enable global tables when the table is empty, so at creation time. If you already have data in a table, you can't create a global table. And then you can enable streams. Streams is the DynamoDB streams. That means that every time there is an activity on the table, we create an ordered stream of data that tells all the updates and the writes on the table. And this is something that you can listen to with a Lambda function, but it's the same technology that we use for the replication of global tables. So you need to enable streams. And then you can start adding regions, and you can add multiple regions. For example, I have here Frankfurt and Ireland as two regions in which the table is replicated. Even if you plan to create a distributed architecture with only two regions, since you can only add the regions at creation time, maybe it can be a good practice to add a third region so that in the future, if you want to add a third region, it's already there. The cost will be slightly limited because you only pay for the database and keeping the database updated, and you create also a disaster recovery outside of the two production regions. On Route 53, you can define a traffic policy where you map the global public DNS name with rules. It can be weighted rules, latency-based rules, and this will go as an endpoint to the public DNS name of the regional API gateway endpoint. And since this will probably be HTTPS, you have to be careful because HTTPS brings a certificate with it. So that means that if you're using a domain here, the certificate for that domain must also be installed on the two API gateways. If you use the Amazon Certificate Manager, there is no cost. You can create the certificate and then assign it to the endpoint. If you have your own certificate, you can load them. But it's important because otherwise, when the HTTP request reach this endpoint, if you don't change that, it's expecting this DNS name that will probably be different from your public DNS name. So you need to add certificates. And then you can define health checks with Route 53. And health checks can be defined in different ways. But the most effective way is to just do an HTTPS request at some specific path. And then you can monitor also the result that is at 200 OK. And then you can do also string matching optionally to see that you contain some specific string in your answer. And you can do standard health check every 30 seconds or super fast every 10 seconds. This will be requests that you get in your application, but are used by Route 53 globally to check if the different regions work. There is also a threshold here. And if the threshold, if you get an error and you reach the number of consecutive errors, this threshold, then we will disable that region at the DNS level, and all the user will be sent to the other region. Having this number small will make moving users from one region to the other faster, but it can also create false positives because sometimes small errors can happen. This is a test that run on the internet. So don't go too low because having a full switch from one region to another is still something that you want to avoid if you really don't need it. Starting from this reInvent, so 3 weeks ago, 2 weeks ago, we now have other features that we can use. So we launched this new service. It's called the AWS Global Accelerator. And the purpose of this service is to leverage on the global network that we have so that if you want to accelerate access to your application running in a region, you can use the global accelerator. The customer will enter in the closest edge location, and then we use our fully managed network to reach the endpoint. And this can work with a single region. So if you want to distribute your application globally with a single region, it will still help customer go through this global network. Or it can work with multiple regions with failover, similar to what we saw with Route 53. So now the architecture is, in the backend is the same. So we have DynamoDB global tables, our Lambda functions. This can be replicated across multiple regions. Then we can use the global accelerator as an entry point, and the global accelerator supports the application load balancer as an entry point in the region. And if you followed my presentation from early this morning, the application load balancer can now route traffic to a Lambda function. So this integration, ALB to Lambda function is new, and the global accelerator is new. And now you can build this architecture that is similar to what we saw before, but has some differences. So this is the resulting architecture, so similar to what we saw before, but we have the application load balancer instead of the API gateway, and we have the global accelerator. So what are the main differences with this architecture? So the global accelerator, first of all, works at IP level. So it can accelerate UDP, or it can accelerate HTTP, TCP, and it's exposing not a DNS CNAME, but it's exposing two Anycast IPs. Anycast IPs are IP address. For now, we support IPv4, and these two IP addresses are the same globally, and depending on where you are, Route 53 will resolve those names. So the global DNS, when they reach our resolver, will resolve that into the closest edge location. So if you have use cases where DNS refresh or DNS respecting the DNS TTL can be complex, you can solve this with the global accelerator because it's IP based, so it works at a little bit at a lower level. And the communication from the closest edge location to the region now is happening on the global on the Amazon global network. So it's better because this traffic here is not going through the internet. You enter in the edge location and then you go through the Amazon global network. We will see other difference afterwards. So with the accelerator, you can create your accelerator. The accelerator can accept different listener for different protocols. For example, here I have TCP on 448 and 80, so the HTTP and HTTPS. And then you can attach to a listener multiple endpoint groups, like I have an endpoint groups in a US East and an endpoint group here in Ireland. And then each endpoint group can have a list of endpoints. In this case, I have a single endpoint and with a weight, and I can send, for example, customer to this load balancer, then we'll trigger the Lambda function. So just to go back, when at region level, we have a traffic dial. So normally, if you keep everything at 100%, we just balance based on the location. But let's imagine that you want to do some maintenance on US East 1. You can just change the traffic dial and bring this low or to 0, and all the user will go to another region. And then you can, so these dials are for your management and not for failover that we do that automatically. And then inside each region, you can define weights, so that, for example, if you want to do blue-green deployment within a region, you can create another load balancer, and then you can move weights from one load balancer to the other to move customer from one version of your application to the other. So if we look at the two architecture, the difference is here. So this Route 53, this is DNS-based. It's using the public internet to reach the API gateway, and then everything is OK. You have lots of functionality for API management here that you don't have in the ALB. Here, you reach the closest edge location, then you use the Amazon global network to reach the region. So the network is optimized, is IP-based. The cost model is different here. As I said also at the beginning, the application load balancer is a little bit cheaper if you have lots of very small API calls, talking of millions and millions. And So it sometimes can be cheaper here. The global accelerator is probably a little bit more expensive than Route 53, but also Route 53, if you enable health check, you have a cost for all those health checks that you get. So cost-wise, they're not so different. Oops. Before the thank you, I just want to show you how this works actually in real time. So we have a little bit of time. So let's start with testing things. So I have here a few endpoints that I created. So this is the so when I implemented this architecture here, I played a little bit, and I'm using the same Lambda function. The API gateway and the application load balancer, they have basically a very similar syntax when they call the Lambda function, and they have a slightly different syntax in the response that the Lambda function must give back, but it's not so different. So I created a single Lambda function that can work transparently with both. And basically, the Lambda function is recognizing if it is an API call or a load balancer call, and then it's customizing. So if we go, if I run this command, I can test this multi-region endpoint. This is using the API gateway. And I'm just reading a record from DynamoDB. And we see that the answer is, this is the item on DynamoDB. This is from an API call. So this is the Lambda function writing that it recognizes this is an API call. And this is the region where the Lambda was executed. It was executed in Ireland. Of course, I'm here, and latency-based routing sent me to Ireland. This other information that you see here is attributes that are automatically added by global tables that tell you that this original write came from Ireland, actually, and then has been replicated in other regions. This was the time of the update in Unix time. And also, if we are planning to delete this record, since deletion can take some time, this is marked as false, so there is no deletion of these records that is planned. If I copy this other URL here, I can do the same on the load balancer. So this was run through the load balancer using the global accelerator. Again, I'm sent to Ireland because I'm in Ireland, but this was coming from the ELB. To see if this actually works, we can use an instance, for example. So using EC2 instances for this kind of test is not perfect because EC2 instances are still inside a region. When you use the global accelerator, normally this is optimized for customer distributed across the world, so that you go to the edge location. If you're inside a region, basically you have, from the region you go to an edge location and then you go back to a region. So it's not optimal path. But for some fun testing, it can be good. So I have an instance in Oregon, I think. Yeah, this one. So let's log into this instance. So this is in Oregon. I should have a key US West 2, EC2 user. OK, now I'm in the instance. So let's copy the same commands that I ran here. So this is the API, so Route 53 and the API gateway, and the second one is using global accelerator. And as you see, now the region I'm going to is US East 1, and in the global table I found the same data because it was coming from Ireland and it was updated from Ireland. So let's have a bit of a look of how this works better. So let's start from Lambda. Let's start from DynamoDB, and then we go to Lambda. So this is the backend that is the common to both. So this is in Oregon, for example, my multi-region table, and it's being replicated across 4 regions. So if anybody tries to build a globally replicated database, you know that normally it's something complex. This is really a few clicks in the console now. So the data is replicated across Ireland, Frankfurt, North Virginia, and Oregon. Here you have the capacity unit. Now all those tables are on demand. If you followed my presentation before, on demand means that I don't need to set up provisioning. I pay by the request. But if you want, you can still use provisioner throughput. When I switched one of the tables to on demand, automatically all the tables were switched to on demand. You can imagine why we do that? Why we move? Let's say that these were all at 1,000 writes per second. And now I switch one table to on demand. So it can support tens of thousands of writes per second.
All need to be same.
Yeah, all they need to be at least with the same capacity. Because if any of these tables has a higher throughput, and then I start using that throughput writing in that table, then the other tables will not be able to catch up because they don't have the capacity to write at the same speed. So it's very important that you keep the capacity at the same level. Otherwise, one region can start to lag behind, and this usually can be a big problem, especially if you have lots of throughput. So this is something that we do automatically. If you change the throughput, it's not automatic, but you will get like a big warning here saying, hey, you have throughput that is not the same in all the tables. You need to synchronize the throughput, otherwise this cannot work, can create big problems. So this is the table, and actually the table are almost empty. So this is the record that we were seeing before. There are 4 records. If we look at the Lambda function, so let's go back to Ireland, the MultiRegion function, and then we'll zoom a little bit. So this is a function. Again, I wrote it in Node.js. And basically, if we look at the main part and we don't look at all the functions, I just look in the, let's zoom a little bit more. In this part here, I'm looking at the input event. And both the API gateway and the load balancer, they send you a request context. But inside the request context, in case of the application load balancer, there is an ELB component that gives you some information. So I look at this. If there is an ELB in the request context, then it's a load balancer. Otherwise, it's an API. And then I have this as the event source. Then I look if there is an operation. This is a read over write. This is and what I need to do with my read from DynamoDB. And then when I read and write from DynamoDB, I get the response here. And then I have this response for function that, depending on the event source, will format the output for the load balancer or the API gateway. And the response format is this one. So this is the generic one, and then it's calling the API and the load balancer that are just above. So this one is the syntax of the API gateway. So the API gateway needs to have a status code, so 200 of K for HTTP normally. And then you can optionally give a body, that is what I'm passing by, and a header saying that is JSON, but this is not mandatory. The application load balancer syntax is more strict, so you always have to tell them if to the application load balancer if this is base 64 encoded. The status code, you also have to provide a status description, typical of HTTP, so 200 of K. Then the headers, and the only optional component here is the body, but since this is all designed to pass a body, of course I have the body also in my function. So with these 2 simple functions, I can create a Lambda function that can pass information both to the API gateway and to the ALB. If we have a look at Route 53, we can see how that works. So I have a hosted zone. That is my demo, danilo.net. And here I have both the MultiRegion and MultiRegion LB DNS. So the MultiRegion, this one is a CNAME that is managed by a traffic policy. So this is for the API gateway. If I go on traffic policy, I see that I have my MultiRegion policy that has different version. And the latest version is this one. That is similar to what was in the slides. But basically, I have the CNAME is mapped with a latency rule to US East and to Ireland in this case. I want to enable the health checks here, and then each one is routed to the DNS name, so this is something you need to put yourself of the API gateway. In fact, if we go to the API gateway console, and we are, for example, in Ireland, I have my MultiRegion API, and that is using my Lambda function. And here I have the custom domain names, and this is where you get, this is the domain name that is automatically generated by the API gateway with a regional API. And then I have to tell what is the domain, the public domain that I want to use, so MultiRegion. And then I need to install a certificate that can cover this domain. So I have a star certificate that is covering all the demo.danilo.net domain, subdomain. But if you don't have these certificates, and if you don't have this, the API gateway will receive a request that it cannot interpret correctly, so you will get an error. So this is a little bit, probably the most complex bit to set up. If we look at the global accelerator, things are a little bit easier. So the global accelerator, I have this configuration with EU West and US East. And then I have the two endpoint groups now for US East and for Ireland. Let's go into the one in Ireland. And here, if you want to add an endpoint, the valid endpoint now are this. So this is a new service, so it may change in the future. So for now, you can use the global accelerator with the application load balancer, the network load balancer, or an elastic IP that you attach to a single instance. So the API gateway is not here. That's the reason why I have this different architecture. And if we go in the EC2 console, I'm downloading the EC2 console. If we go in the EC2 console, let's go in Ireland. I have here the load balancers. And here I have my multi-region load balancer that has a listener. The listener is forwarding all HTTP traffic to a target group. The target group is as a configuration that is sending everything to this Lambda function. And this is the new part, the new bit that comes from reInvent. Now you can put into a target group a Lambda function similarly to what you would normally do with an application with an autoscaling group or an EC2 instance. So this is the overall description of this architecture. There are pros and cons in both, so not one is better than the other. It depends on your use case. Normally, the most important thing is to decide if you want to work with IP address or a DNS-based solution, if you need network acceleration, or if you're OK with your customer going to the closest region using the public internet. Thank you. We have some time if you want to ask any question on these or things that we saw today. And then we have a short break of 15 minutes. And at 45, we started the final session. That is probably the most opposite topic after this session is how to build serverless backends using GraphQL. Any question? OK.
This morning, you explained about the Dynamo transactions. What is the impact by using, Dynamo configuration on-premise and with the other configurations that you said might have some complications?
So transactions by default are enabled for all non-global tables. If you have a global table, transactions by default are disabled because we can't assure that a transaction is all or nothing on a replicated table because there's too much latency between. So that means that by default, you can't use transaction. If you want in a global table, you can enable transaction. But if you apply a transaction on a table here in Ireland, and at the same time you do a transaction in US East, we can't assure that the two transactions work seamlessly as you would expect. So normally the use case for enabling transaction with global tables is disaster recovery. So it's not active-active, but you have another region where you know that there is no activity, or you are sure that you are not working on the same records as the other region, and then you can use this feature. But you need to enable it at table level, because by default, global tables have transactions disabled.
Okay, thanks. So just one last question. Dynamo transactions, they have ACID properties?
Yeah, the DynamoDB transactions are fully ACID-compliant transactions, and they work across a single or multiple tables, but they must be in the same region and in the same AWS account. Do that when across regions is too slow. It's impossible, because when the latency goes above, I think, 20 milliseconds, 30 milliseconds, synchronous activities like this are too slow and doesn't make sense. Any other question? Okay, we meet again, I hope, in 20 minutes, so we start at 45, and then there's the last session of the day on a completely different topic. As I said, we will talk more about GraphQL and how GraphQL works and how to use that with mobile and web applications.